Okay, so what we have here is we've taken a standard Yeti 64-ounce Rambler bottle. They don't make them anymore. I think they've replaced them with their gallon and half-gallon jugs. What I did is I took it, I loaded it up with ice, and one of the things that's always frustrated me about a lot of these videos that show how long they can hold ice and temperature for is they always open it to check it. So what I've done to solve that problem is I have a couple scientific grade temperature loggers. I have one that is silver here that is submersible from the Onset Corporation, and it can log anything from -20 to just slightly above boiling. And for the ambient temperature, I also have another logger from Onset, and this one is going to log the ambient temperature. Both are accurate to 3 decimal places in temperature. This wasn't NIST calibrated, that'd be a little bit overkill. But now we can see exactly what's going on for a long period of time. So now all that is left is I threw it in my car, as shown here, and let it sit out for a few days. 422 hours and 19 minutes to be exact. So what this graph is looking at the maximum minimum temperatures of both the ambient and the Yeti tumbler. We have the Yeti in blue and light gray here, and looking at those we can see where the maximum minimum temperature comes up, and we can see how the maximum temperature here of the ambient, pushing over 100 degrees, just as the difference between the graphs shows us that there's more radiant energy hitting this than there is less cooler temperatures hitting it. So we have a net gain of heat, and thermodynamics says that the heat is going to go to the cooler place, which in the vacuum, that's going to start raising the temperature of the Yeti, because it's cooler there than it was outside of the Yeti for the majority of the time during the summer. So what we can see here is that from the lowest point to where it gets to about 50 degrees, we can see that it takes that this Yeti cooler gets to about 50 degrees in about just under 2 days, and that's fighting extremely hot weather. We can see that we start at the lowest point here, and then about every 10 degrees, I consider that a critical point. And about 50 degrees, it takes it almost 2 full days. We look at the temperatures for 2 full days. We can see that 50 degrees, it got as hot as 135 degrees in the car. So here, what we can see is this is the ambient temperature sensor that was left in the car, and we can see in the summertime what it's doing. I mean, it was not exactly a cool time here, and we're seeing 138 degree peaks, 139, another 134. This is inside the temperature of a car. It's also why you don't leave small dogs in cars, because it's like sticking them in the oven. I mean, 141, 142 degrees, 125. One day it was cool because it rained, but it got up to 80. But every other day, 113, 100, and it stays above 100 a good chunk of the time. So now that you've seen the graphs, I want to briefly go over the results and explain what's been going on. Basically, the vacuum seal inside the Yeti bottle is what regulates and slows down the heat transfer of cold getting out or heat getting in. Because of the day-night cycle, the water inside never gets a chance to cool down. The vacuum, which regulates the heat going in and out of it, holds it so well that by the time the sun comes up for the next day, it's heating up and it never got a chance to come back to where it was, which is why the cold lasted about 2 days. Now it's going to leave a lot quicker, but when you start adding energy, it actually takes it longer to dissipate than it can before it starts to come back into the tumbler. So as a consequence, this is how you saw a 60-degree change from 32 degrees all the way up to 94. There is one more thing in closing, though. I do find it a shame that Yeti or any other high-end cooler company doesn't have an educational program. The reason being is little experiments like this are well within the reach of elementary school children to get them involved in the science, technology, engineering, and mathematics, in this case thermodynamics. But there'd be so much kids to learn, and whichever company would ever create one would benefit because they get their brand out to an audience at a younger age that will remember them from their elementary school experiments.